Okay, picture this. The alarms are blaring, but they're completely silent. Digital tripwires have just been crossed, and deep inside a network, an intruder is on the move. Now, this isn't some scene from a movie. It's the real-deal start of a cyber incident. And today, we're going to go behind the curtain to find out what happens in those critical moments after the breach.
So a hacker is in. They've bypassed the defenses, they have access. What happens now? Well, you might think it's just pure chaos, but it's not. It's actually a highly structured, methodical hunt, and it's led by a team of cyber first responders. Let's dive right in.
You see, every response follows a kind of playbook, a roadmap that's designed to manage the crisis. It all starts with detection and analysis. Then it moves to containment, to stop the bleeding. After that comes eradication and recovery, to clean up the mess. And finally, and this is crucial, post-incident activities to learn from what just happened. So let's break down that first phase.
An alert pops up on a screen. A system starts acting, well, weird. This is that first signal, the moment the hunt for the intruder officially kicks off. But, in these first few moments, the most seasoned responders don't immediately ask, where are they? No, they ask something way more fundamental.
It's this question right here. Did an incident actually happen? And believe it or not, this is one of the toughest questions to answer. See, not every alert, not every weird little signal is a real attack. So the number one job for any incident response team is to separate the real, genuine threat from all the noise.
And this really lays out the challenge perfectly. Responders are just flooded with unreliable clues. You've got conflicting signals, faulty reports, totally inaccurate alerts. They have to slice through all that junk to find the hard evidence, the concrete proof you only get from system logs and something called indicators of compromise.
Okay, so once they have a strong suspicion that this is the real deal, the investigation really kicks into high gear. This is pure digital detective work. It's a hunt for the attacker's tracks for that undeniable proof of what they've been up to.
And the main target of this hunt? It's the indicator of compromise, or IOC for short. The best way to think about these is as the attacker's digital fingerprints. They're the little artifacts left behind, a weird file, a suspicious IP address, an unusual network connection that act as stone-cold evidence of a breach.
So where do they find these fingerprints? Well, mostly in cybersecurity logs. These logs record pretty much everything that happens on a network, and they can tell the entire story of an attack, from beginning to end. But here's the problem. A typical network generates just a mountain of log data. Finding that one crucial clue, that one IOC, is literally like trying to find a single word in an entire library of books.
So the moment that threat is confirmed, the priority shifts instantly. It's not just about watching anymore. It's about acting, and acting fast. The goal is to stop the intruder from going any further. It's kind of like quarantining a patient or building a fire break to stop a wildfire from spreading.
And to do this, responders have a whole toolkit of techniques. They can try to just kick the intruder out directly, or what's more common is they'll isolate infected machines, just take them right offline. They can also segment the network, basically building digital walls to block the attacker's path. And sometimes they'll even reverse engineer the malware itself to figure out exactly what it's trying to do.
Right, so the main point here is that containment is all about speed and control. The goal is to stop the digital bleeding, and to do it immediately. This phase right here, this is what prevents a minor little intrusion from spiraling into a full-blown, catastrophic data breach.
Now, with the threat contained, the cleanup can finally begin. This is what's called the eradication and recovery phase. This is where responders work to systematically get rid of every single trace of the attacker and then safely rebuild any systems that were damaged. But it is not as simple as it sounds. You can't just find the malware and hit delete. You can't just reformat the hard drive and call it a day. Nope. Modern malware is specifically designed to survive that stuff. It can hide in parts of a system you would never even think to look.
What's so wild about this is just how thorough you have to be. To really truly get rid of the threat, responders use a process called data sanitization. A really common method is the Department of Defense 3-pass wipe. First, they overwrite the entire drive with the number 1. Then, they do it all over again with zeros. And for a third time with random characters. This makes sure that not a single fragment of the malicious code can possibly survive.
And what if a drive is so badly compromised that even that whole process isn't considered 100% safe? Well, then it gets physically destroyed. And I mean, we're talking about industrial shredders that shear the drive into tiny metal flakes, or giant presses that crush it into a little block. Yeah, there is no coming back from that.
So, the systems are clean, they're back up and running. But the job still isn't over. In fact, you could argue this is the most important part of the whole process, learning from the attack. This is where digital forensics comes into play, to piece together exactly what happened, why it happened, and how to make sure it never happens again.
But think about it. In a digital crime scene, evidence is unbelievably fragile. I mean, it can vanish in a nanosecond. So where do you even start looking? Well, the answer comes from a core principle of digital forensics.
And that principle is called the order of volatility. It's a fancy term, but it's a simple idea. Investigators have to collect evidence from the most fragile sources first. Data in the CPU cache, that stuff changes constantly, so you grab it first. Then you move on to the RAM, which gets wiped the second you power off the machine. They basically work their way down this list, from the most fragile stuff to the most stable evidence, like data sitting on a hard drive.
And during this entire process, every single piece of evidence is handled under a super strict chain of custody. This is basically a meticulous log that documents who touched the evidence, when they touched it, and why. It's all to make sure that if the case ever ends up in court, all that digital proof is 100% legally sound.
You can't improve what you don't measure. So these teams track key performance indicators like the mean time to detect, basically how long did it take us to find the breach, and the mean time to remediate, how long did it take to completely fix it. And the goal, always, is to get those numbers as low as you possibly can.
And this quote really just gets right to the heart of it all. The goal isn't just about getting the systems back online. The real win, the true victory, is using the painful lessons from an attack to build stronger, tougher defenses for the future.
And all of this leads to what's called a root cause analysis. The investigators dig deep to answer the ultimate question, why did this happen? Was it a bug in the software? A gap in security policy? Was it just human error? By finding and fixing that root cause, they can stop a whole class of similar attacks from ever working again.
You hear it all the time now. A cyber attack is a matter of when, not if. But as we've just seen, the initial breach, that's just the beginning of the story. The real test of an organization's security isn't just about if they can stop an attack. It's about how they respond when one finally happens. The real test is always about what happens next.